Welcome everyone, thanks for joining. And this is about leveling up your test. And there we go. So a little bit about me. My name is Raúl Portales. That's my Twitter handle. I know it's very hard to pronounce. Most people in English-speaking countries call me Raúl. I'm fine with that. Only Spaniards actually pronounce my name correctly. I'm a principal software engineer at Workday in Dublin, and I've been here for 3 years, and we've been working on the Android app for Workday. I assume a few of you will actually use it in your day-to-day work. I'm also an Android GD, like a Google Developer Expert. I've been part of this program for, I think, about 5 years, and I've been going around in conferences, DevFest, and all the other stuff, and it's been a lot of fun to share with the community. And I do like RPGs. You may have guessed that by the title of the talk. I play a lot of Zelda. I recently played The Witcher 3. I thought it was going to be a fun thing to give into test to talk about leveling up. And I do not like complicated code. I've been doing Android for more than 10 years. I've been a software engineer for 17 years. And no, the more complicated the code, the worse. We have to write code that is easy to read. And if code is complicated, I don't like it. Before I actually dive into the talk for today, tests are a part of code quality in general. And why we want code quality and what does code quality mean was a topic that I actually discussed in a larger talk a few years ago. It's actually on YouTube. You can find it in Mobilization. It's a conference in Poland. It's the guys that actually recorded it. And if you're interested in the wider scope, not just tests, but code quality in general, why and what are the low-hanging fruits that you can do, I encourage you to go there and check it. And yes, there's a Terminator in the picture. So, tests. Maintaining code, especially large code bases, is risky business. It's like playing trapeze, and you want a safety net. And the tests are this safety net for your maintenance. And the longer Android is on the market, you see more and more apps that are living longer, and they have code bases that are bigger and that they need to be maintained. In the early days of Android, we just write a simple app, we publish it, done. But over and over, the apps are living for longer periods of time. They get more complex, they get to be maintained. Therefore, tests are more and more important. Leveling up, you look at the dictionary, it says is to gain enough points in a computer game to enable a player or a character to go up to a higher level, gaining more skills or strength. Or it's also to go to a higher level or standard. So that's what we want to do. We want to take our test to a higher standard. You can write tests, but over the course of the past years, I've learned that the way I wrote tests at the beginning was not the best way, and there was some practice that weren't obvious that can actually help you write better tests and make the test be more useful for you. And yes, I know I have the high ground. This is it. It's over. I have the high ground. So you underestimate my maintenance cost. Sorry, I have to put a Star Wars reference in here. Now, what are we going to do today? I'm going to do this quest with better assertions, first part of the quest, another one about random inputs, which is like a side quest of the assertions, and then another part, which is wider units. It's like a multi-step quest, open world, if you like. So let's go. Let's go on an adventure. Let's see what we can do. What do we mean by better assertions? Like when you write a test, you should be always trying to test what this code is doing and not how it is doing it. If you test for how the code is written, you are actually tying yourself to the implementation. And that's not a good thing. You should be able to look from the outside of the unit and say, okay, what do you do? Not how do you do it. That's an implementation detail. If you refactor the code, the what should be the same, but the how can be completely different. So if your test tests the how, they're going to be invalidated when you refactor. And you have to cover negative test cases too. You just cannot just write the positive tests. You need to write tests for the wrong behavior as well. So let's do this example. An email validator, which we are going to implement, and it has a function that we call is valid, and another function for the username, and another one for the domain. Very simple thing. We just have an email validator, and we go through the test, we go through the code, we find it, we check for tests, and we find this test. And it looks good. Like, you look at the name of the test, it says, given a valid email, when I check if it is valid, then it returns true. This is something we do a lot, and I see a lot of people don't do that. In Kotlin, you can use the back quotes to put spaces in the name of a function, and then you can write the function in a very descriptive way, not camel case underscores, but something like this. And this is also written in a BDD style that, I mean, it's not using Cucumber or Herkin syntax, but it gives you an idea of, this is my initial state, this is what we do, this is what we expect. But in this case, we got an email which is username@example.com. We instantiate a simple email validator, which is the class we're testing, and then we assert that the email is valid. So far so good. But the problem with this test is that it looks good, but it isn't good enough. And when you're doing serious business like playing trapeze, and you're counting on this to be your safety net, it has holes. And that is very dangerous. You need your test to be a proper safety net, not a safety net with holes. Why do I say this? We got this implementation, and this passes the test. I know, it returns true. And if you ever done TDD, you know this is the first implementation you will do. It's like, why do I care? I just return true. All the tests are green, work done. Like, yeah, I know, you should never do this in production, but imagine that you return that is valid in a combination of multiple functions with, like, if it has a valid username and a valid password, and somehow when you're refactoring the code, one of these functions returns true, and you change the and for an or, and suddenly you have an expression that doesn't look like it always returns true, but it does, and then your test don't get it. So you will probably not write a return true like this, but accidentally refactoring, you may actually end up in this situation. So we should write negative cases. For example, given no @ symbol, when I check if it's valid, then it returns false. And I got the username, no domain, and then I assert it for false. And also given empty username, when I click if it is valid, then it returns false. And now we have @example.com, and then we assert for false. Now our previous implementation doesn't work anymore. We have to actually do an implementation that returns true for certain values and false for others. And now we have a proper safety net. And this is as simple as an email validator. Real code can be a lot more tricky to find out that we are not doing all the assertions that we need. And in addition to this, adding extra cases increases code coverage, which is always good, right? Because good tests have high coverage. Why don't we go and we aim for high coverage, right? If we have, our code base has a high level of coverage, that can only be good, right? Well, no, I'm sorry to tell you, code coverage is an empty measure. It's a byproduct of making good tests. If you try to increase your tests by increasing the code coverage, you're going to look at the code. You're going to look at which areas are not actually being covered, and you're going to write test cases for those areas. And it's almost impossible to not write tests that test how the code works, not what the code does. And in addition to all this, if we go ahead and we remove the assertions, assert true, gone. Assert false, gone. Assert false, gone. Now we have the exact same test coverage than we had before without the assert. The asserts don't add any test coverage, but now all these tests, they are always green. So these tests are absolutely useless, and we have the same test coverage as before. Therefore, if you just aim for test coverage and we don't care about what are we testing and we assert what is happening, test coverage is actually useless. Why did I remove the assets? Yeah, I know, but why did you go and remove the assets? You're silly. Like, no, because I had them before. But when people are in a rush writing tests because they have to fill the tick like, oh yeah, the code is tested, they just exercise the code and they forgot to assert for the right things. And it's not that you are going to remove the assets, but you're going to forget to put them in. And then you will think you have a test that does something, but in fact, it never fails. And a test that does not fail gives you no information. It's like a traffic light that is always green. What's the purpose? You can just remove it. It does nothing. And I've seen a few of these though. So we recap, we talk about assertions, talk about why you should test the what, not the how, and how assertions are actually the most important part of the test. And they come when you test the what, you should know what you should be asserting. And the negative cases are the ones that gives you confidence. So the spec library can be helpful in writing BDD you did in Kotlin Mercury. Yeah, I have not tried that one, but thanks for the point. I will take a look. So I'm moving forward into random inputs. We got this test again, same class, got given an email. When I get the username, then I get the part before the @ And we got username and example.com, got our email validator. We retrieve the username and we assert that it is username. Pretty good, right? Well, not really, because it's again a safety net with holes. And why I say that? This test look pretty good. Well, not really. You get this dummy implementation where I return username, hard-coded string for username, and example.com for hard-coded domain, and the test passes perfectly, no problem. And yeah, I know. Why would you return a hard-coded string? Well, again, sometimes you do something temporary and you don't have time to finish it, and because all the tests are green, you forget that you put something temporary in there. Sometimes in the refactoring, you are not really sure what is happening, and you just put something that works for now, and errors can happen. So you think this is crazy. It isn't. And if you ever done TDD, this is the first implementation you do, and TDD forces you to write more tests to make this fail and do a proper implementation. Now, you don't have to do TDD to write this kind of test. It is impossible to do wrong tests with TDD, but you can learn the lessons of TDD to write better tests without having to go TDD all the way, which I think you should, but that's a different story. Instead, we can create a random input, because we could create a test with username at example.com and another test with my name at mydomain.com, and then check that each one of them returns something. But we can take it farther. We actually look at the title of the test. When I get the username, I return the part before the @ So what is the part before the @ It doesn't matter, something random. And you got uuid.random uuid to a string built in Java and in Kotlin, and it just gives you a random string of uuid, which you can use for whatever you want. And now you can actually verify that what you put in there is what you get back. So every time you execute this test, you will have different test cases. So you cannot hard-code anything. As I said, this was a side quest. And now we go for wider units. So I got another question. What's your recommendation to convince the business that good tests are more important than coverage? That is a very good question. Like, you just saw them that if you do test coverage without proper asserts, it's not useful. And you have to write tests that are verifying your behavior. What we do is we get our QA people to review the tests we actually write to see that they are happy. And business at the end, what it wants is code that works and that you ship faster. And your tests are there to help you ship faster, because it's a safety net. So you just tell them, if I write good asserts, my test is going to be good. And also, the code coverage is going to be there as a byproduct, but it shouldn't be our target. If you don't have it, it's a bad sign. But aiming for it and pushing the engineers to go for test coverage is not a good idea. Not sure if I actually answered the question. I hope I did. Okay, so into the last step, wider units. What does this mean? So let's take a step back. We have our email validator there. We have our new create user screen, right? We have a registration form for our new users, and they're gonna, one of the fields is their username, and they have to create a user there. And we already have unit tests for the email validator. And now we have a new class, which is create user screen. Therefore, we already tested email validator, so we mock it, and then we test explicitly what is inside create user screen. This is a very obvious way of thinking that is also not great, because Mockito says in the official documentation, in the official front page, do not mock types you don't own, don't mock value objects, don't mock everything, and so love with your test. And I want you to focus on don't mock everything. So what will happen when we go to test this create user screen? So first we have a test that we want to write to test something. We have it there in the bottom. And we want to create user screen that will receive something, right? And then we have an email validator that we want to mock. But because the email validator that we have is actually built on every instance, we now need a factory. So now we have to create an email validation factory. And every time you call create email validator, it will return this email validator that you mocked, and then you can start mocking it. And when you look at it all together, it is a lot of code. Aren't you concerned that the random input will compromise your test deterministic features instead of reducing some flag? That's a really good question. That's a really good question. The randomness will introduce the possibility that if you're testing for, I don't know, a URL, that it will generate a URL that is actually matching for something else. The last time I checked, for us, it was 1 in a billion. So the chances that your CI/CD pipeline fails the test on this particular case is less probable than a failure on the disk. If you're really concerned, you can always dismiss the other cases. So when you're creating a random value, say like, if the value is one of these that we know are different, give me a new one, and then you're safe. You cannot do it for everything. Sometimes you want to verify other stuff, but for a lot of things, randomness is actually allowing you to verify that the actual value is there. How would you recommend to test mappers? I'm not really sure what you mean by a mapper. If you can elaborate, I'll go back to it later. Also, what about when you have a mapper injected somewhere and test the class where the mapper is injected? Oh, that. So injecting is complicated. I didn't want to go into testing injection, but if what you're injecting is a type, if what you're injecting is a value object, then that shouldn't be mocked. You can create an implementation of this mapper, and then you can inject it on your test as injecting a new value, or using Dagger test overrides. You can override your DI for test, for example. But ultimately, I would say it's an implementation detail, and you don't want to go that deep. But I think it will be more clear when we go a little bit further. Yeah. Oh, I'll go into this a little bit further because I want to follow the wider units. Anyway, so when we look at the entirety of things we have to do to mock the email validator inside the create user screen, it's a lot of code. Instead, you have tested the email validator, that's all right, But this thing, this create user screen is actually a unit on itself. So you just instantiate it and test it. Because the fact that this uses an email validator inside is just an implementation detail. It's testing the how. Okay, so you may not be convinced yet. Let's go a little bit further. Imagine this example starts growing. And we have a username that is an email, but what about they decide that you can also validate phones as usernames? And how about the password? We need to validate the password. And how about the address, for example? Do we need to validate the physical address as well? And now we have 5 classes. And do you really want to mock these 5 classes? And how about maintaining those tests? Every time you change an implementation detail, if you want to remove one of these validators for something else or a different pattern, you have to change all the setup of all your tests. More importantly, is mocking those classes right? And I think it isn't, because these are all implementation details. These are internals of the class. Therefore, unless you're going to have a secondary implementation of these classes, you should just instantiate the ones you have. And if you have multiple possible implementations, then fine, you can mock it. But the point of mocking is to verify interactions between components. So right now, what you are doing is you are verifying the interaction between the create user screen and the other components, which are internal. Therefore, you're verifying an internal contract, which is an implementation detail. Mocking an external component and see how 2 parts of your app talk to each other and verify the protocol is perfectly fine. But over time, I found that the less things you mock, the better. And in particular, Mockito tells you. So they are the guys that made the framework and they tell you not to use it. So they probably have some interesting ideas about that. So as I was saying, the other way to look at this is that this is not a relationship of usage, it's a composition. This is an implementation detail. And as long as you see these classes as implementation details, you should not mock them. And now, back to the original question. If you have things that are injected via DI as mappers or whatever, if your mapper only has one implementation, by all means, use the only one that you have. Make it injected. The same way it will work in the official application and make it go. Why shouldn't you? And if you have the possibility of have multiple different mappers, then you can create a mock object, and not actually a mock, but a fake object that implements this mapper with whatever you need, which is a little bit more complex than just a mock, but it's a real object. And then you can use dependency injection, overriding the bindings for testing to actually test it with this one. Or you can just use a inject constructor with optional parameters and pass it there. Most of the times I would say something that you are injecting, you don't really care. You just inject the real thing and let it work. Now, again, don't mock everything. And with that, we are actually at the end. And I'm going to go back to the questions. In the random inputs example, you made the test non-deterministic. Would that make it hard to fix the bug when it starts to fail only in some cases? I haven't seen that happen so far, because when a test fails, it fails for doing something in a particular way. And I mean, you cannot always randomize everything. But if you are randomizing something that is an input and you're verifying that same input as at the end, for example, when I get this URL, I actually call the service in the same URL. You can completely randomize the URL and verify that what you're calling is actually mapping. And I have not seen them introduce any flackiness. I mean, if you're going to do visual test or screenshot test, sure, randomizing those will be a nightmare. But any sort of assertion, even visual assertions in Compose or in Espresso, you can always assert for the random component being there. Regarding hard-coded values when using TDD, what if you don't allow yourself to hard-code values for the sake of making the test pass? Even if you do, shouldn't you address the hard-coded values at the refactoring stage of TDD? Well, yes and no. I mean, if you take TDD super strictly, you should make the simplest implementation. And if the simplest implementation is to return a hard-code value to make the test pass, so be it. The refactoring part of TDD is about, oh, my code has gone very complex. Maybe I should clean it up. But if you haven't written a secondary test that forces you, for example, if the username, if the input is username at example.com, return username. If the email is my user at mydomain.com, return my user, that spots, that is something you spot on the refactoring. It's like, look, this refactoring is clearly incorrect. But return double quotes username doesn't jump at you at something that is clearly wrong, while the other if, when you have two cases, is already jumping at you for something you have to refactor. So you can do it whatever way you want, but the risk is not that you implement it as a hard-coded value, is that while you are doing refactoring of this code, accidentally you start returning a hard-coded value because errors happen, you have abundance of sleep, you're distracted by something, the code is very complex, or you are trying to solve 5 different tickets at the same time, and accidentally in the middle of the refactoring, you return a hard-coded value. And this can happen. You just need enough people working on a large enough piece of software, and it will happen. Okay, so with this completed, I was going to opt for questions, but since we already got a lot of them.
Well, happy to stick around too for a minute, Raul, if you have any questions, or if there's any questions that come in. But I think you did a good job getting onto all the questions during the presentation, so I think we're in good shape.
So I hope you take some of these ideas and try them out, because I learned them the hard way. And the idea is that you don't have to go the hard way to take advantage of this. Think of this as going in a party with a person that has gone through all the dungeon already and has all the skills and knows all the traps and everything and stuff. Don't step on that, don't step there, just wait for here. There's coming this guy, oh, prepare a fireball, all these things. You don't have to know them if someone's already gone through them. But I guess most of us have to learn by making the mistakes ourselves. But if I can save you some painful time and I can help you lift up the quality of your test and make your maintenance better, I'll be happy that is what I intended. So if that talk succeeds at that, I'm more than happy. Oh, one more question. Is there an objective, measurable way to assess the quality of your test? Not that I know. If someone finds a good one, I'll be more than willing to go for it. I always say TDD is the best way I know to ensure that the tests you write are good, because you cannot write bad tests when you do TDD. That being said, I'm not married to TDD. It's a tool. If you find me a metric that can measure the quality of my tests and I can do them any other way and it's simpler, I'm sold. I jump ship tomorrow. But so far, I'm sorry, I don't know anything that can verify the quality of the test. I don't think anyone has found it yet, unfortunately.
Well, good, Raul. I think that wraps it up. Thanks so much. Appreciate you taking the time to answer the questions and sharing your insights with us today. Always an important topic. Always we can improve on tests no matter what. And so always good to bring this to the forefront of what we're talking about. So really appreciate you being with us here today.
Thanks very much for having me.
All right. We'll catch you on the other side sometime. Thanks so much, Raul. Take care.
Take care.
Bye-bye.